And this problem is a continuation of problem 6-63. It's using the same data, but now a different methodology to break down your mixed cost into your fixed and variable. So whereas in number 63 we used the high-low method, which is it's quicker and faster to use, but not quite as accurate as, say, using the regression analysis. So in this problem we're using regression analysis to do the same thing. So when you run the full regression analysis, you get a lot of data, but you're really not using everything. Because all you're interested in when you're running the regression analysis, you want to look for your R-square. So your R-square is telling you how good your, in this case, your direct labor hours are as a predictor of your total cost. So is there a relationship between cost and direct labor hours? So here it's 0.96. So the closer the R-square is to 1 is telling you it's a really good fit. So if that had been 0.10, like 10%, then you know there's not much of a relationship between labor and total cost. So this is telling you that the output is going to be something you can rely on because it's close to 1.96. Okay, so here the intercept is your that is your fixed cost, and your variable, the x variable 1, this is your variable cost, also known as your slope. So when you run the data, all you need to do is go in and look for your x variable, 2.20, so 12.20. So when we use the high-low method, the variable cost per unit was 12.75. So with the regression, it's telling you that it's 12.20. Your fixed cost, that's your intercept. So that's 191,235.42. So that is your fixed cost. And again, you are telling, it's telling you that this is your formula. So what this allows you to do is substitute any volume in here, and you can then predict your total cost. So that's, when we insert our volume, and in this case we're told to look and calculate what the cost would be if our volume was 24,000 units. So at 24,000 units, your total cost is going to be 484,035, whereas when we did that same thing using our high-low method rather, we saw that the total cost was actually 488,750. So there is a difference here when you're looking at your total cost. So that is requirement 1. So requirement 2 is saying, well, use regression analysis, but instead of using the number of direct labor hours as the driver, what about using the number of units produced? So look at using volume. So you're going to use the same cost, but you're going to select volume as your cost driver. So we're going to see, first of all, is there any relationship between the number of units in terms of your output production and total cost? So here, of course, the first thing you're going to want to look for is your R-square, 0.57. So this is not nearly as good a predictor. So what this is telling us is that the number of units produced, while there is a relationship, is not nearly as strong a relationship as with the number of direct labor hours. So you follow through the same process. Here you would use your intercept. So the intercept, again, that means that's your fixed cost. And the variable is 34.80. So this is our variable cost here, and that's where the 34.84 is coming from here. So again, you have now generated your formula. So now it's asking you, well, using that formula, what about if you produce 5,000 units? What would your cost be? So it would be 500,000 for 96. So the cost, because of the R square being so much lower, 57 versus 96, then it's not as good a predictor of your total cost as direct labor hours would be. So you really wouldn't recommend to the company to use the number of units as the driver here. So the third scenario we're looking at here is requirement 3, again using regression analysis, this time to remove any potential outliers. So you'll recall when we did the graphs back in an earlier problem, we saw that September was an outlier. So if you think there's one month that's not representative of a typical month, you'd want to exclude that from your data to see if you can get a better result. So in number 3, we're doing the same calculation, but all we've done in number 3 is eliminate September from the list of data. So this gives you a better R square, 0.83, and you come out with a formula that's giving you a variable cost of 36.37 and your fixed cost of 329,000. So your total cost here, it would be 511,000. So with that R square, of course, it's seeming to indicate it's a much better fit because you've removed September. It's an outlier because it's not a typical month's data. So part 4 is asking us which of the methods, which of the equations do we have the most confidence in, and with part 4, of course, we're going to have confidence in the first one because it had the highest R square, 9.965. So the one you'd want to select is the one with the highest R square because it's giving you a better picture and a better indicator of the strength of the relationship between the number of hours of direct labor and total cost. Now, when you're looking at the data, you would have observed, of course, these formulas, when you do the full regression analysis, is giving you a lot of information that you don't use. You're only using your R square, your intercept, and your X variable. So if you just wanted to calculate just those, you can, of course, do that in Excel.
So when we looked at the official solution to this problem, you'll recall that there was a lot of data in the solution that you don't use, and all you really use is the R square, the intercept, and the slope, so just these 3. So I'm just going to demonstrate now how you would calculate just these 3, because that's all you really need to do when you are using regression analysis to break down your mixed cost into fixed and variable. So first of all, if we want to find our slope, so then you just would select more functions, statistical, and we'll scroll down here until we come to slope. Select slope. Then it's going to prompt you to enter in your y's, which would be your cost, and the x's, which would be here your hours, and we hit OK, and it calculates your slope. So that's the 12.20. So the slope means your variable cost. So to do the next one, if we want to do our R square, for example, same thing again, more functions, statistical, we'll scroll down until we find R square, and again this is going to prompt us to enter in the y's. The y is of course going to be your cost, and hit enter. Then select your x's, so that's going to be your hours, and it gives you your R square, 0.96. And the final one we're going to look for is the intercept. So the intercept, again, more functions, statistical, scroll down till we see intercept, and it's going to prompt us for the y variables, which is of course your cost, and the x variables, which will be your direct labor hours. Hit OK, and you'll see it's calculated the intercept. So if you're using this functionality of regression analysis to calculate your fixed and variable cost, or to break down your mixed into these two components, then you don't have to calculate all of the output. You can just calculate the three pieces of information that you are looking for. So this concludes the Excel demonstration of problem 6-64.